All right, lesson number 10 is on integrated rate laws. Integrated rate laws are equations that can be used to relate concentration and time. So they're basically there to say, hey, at a given time, this is the concentration I'm going to get. Now, there are three different integrated rate laws we learned about in class. One is for zero order, one is for first order, and one is for second order. And they all have a setup that gives us an equation of a line, y equals mx plus b. And so if we graph something versus time, we'll get a straight line. And that something that we graph depends on the order. So for instance, if I graph just the concentration versus time, and that gives me a straight line, that means it's zero order. If I graph ln of that concentration versus time, and that gives me a straight line, then it'll be first order, and I do 1 over a versus time, and that gives me a straight line, that means it's second order. So I did that for some data from an experiment, and I get these three graphs. Which one of these three graphs is a straight line? The answer is the first one here. So that means that our reaction is zero order. So I can go ahead then, and now that it's zero order, I can go ahead and I can say, all right, I know what this equation is going to be like. I know the equation for this experiment. And from that, I can find out the value for K and then also the initial concentration. All right, so we're going to do the rest of this on the board. So if it's zero order, that means that the concentration of A at any given time is equal to negative KT plus A naught. Okay, now on the graph there, we have Y equals negative 0.005 times X plus some value, 0.45. So that means that Y is my concentration and X is my time. And so negative K equals negative 0.005. So that means K is equal to 0.005. What are the units for it? Because I asked for the units. Well, the units are going to be such that when I multiply by X, I get the units here, right? So remember that concentration is in molarity. So I have molarity equals negative K times minutes plus molarity. So that means my K must be in something that when I multiply it by minutes, I'm going to get molarity. So it must be in molarity minutes to the minus 1. Because when I multiply this times minutes, those are going to cancel out and I'll get molarity. Because molarity plus molarity gives me molarity. This is going to be molarity minutes to the minus 1. Notice how in the rest of the lesson, I was always using per second. Well, this is a reaction per minute. In the same way that I can talk about speed in miles per hour or kilometers per minute or meters per second. All of those are speeds. Right? Okay, so that's my value for K. The other thing it asks for is my initial concentration. Well, my initial concentration is going to be this. Okay, so that's A naught. It's going to be 0.45. The units for concentration we've been working with is molarity. All right, so that is how to use integrated rate laws to figure out values for K and initial concentration. Okay, so now let's go on and let's do video problem 10B. All right, in 10B, we're told we have an initial concentration of 12 molar, and we want to know how much is left after 240 seconds. In A, we're told to use the fact that it's zero order, and in B, we're told to use second order. So let's go ahead and do this problem. All right, so if it's zero order, that means that we have this equation. This equation relates the concentration at any given time, that's AT, to KT and my initial concentration. All right, so what is my value for K? My value for K is negative or it's just positive 0.11 molar seconds minus 1. This is given to us. In the last problem, we had to find it. This one's given to us. This one's in seconds. That was in minutes. Okay, Sarah. All right, that's my K. I'm told that my initial concentration, that's A naught, is 12 molar. Okay, and we want to know at 240 seconds what my concentration. So I can just plug these all in because I'm told it's zero order. 0.11 molar seconds times 240 seconds plus 12 molar. All right, when I do this, I get as a value 0.11 times 240. I get negative 26.4 molar plus 12 molar. And I look at that and I say, all right, this is going to get me negative 14.4 molar. And that's my answer. But then, before I move on, I have to realize I can't have a negative concentration. I can't have a negative concentration. So, what that means is the answer is 0 molar. Because if I use this, it's going to get me negative concentration because it doesn't realize that that's not a possibility. Math sometimes doesn't realize this. Okay? So if I get a negative value, the answer is 0 molar. Right? Now this is a zero order. Zero order, I need to be careful about this. Let's look at B, which deals with it for second order. All right, so here's that data on the screen. Now let's try B. Now B, we're told the same information, except we're told that it's second order. Okay, so we're given a value for K, but it's second order. That means this no longer applies. For second order, it's now 1 over AT equals positive KT plus 1 over A naught. Okay, so I can go ahead and I can plug this in. So 1 over A at T at time T equals 0.11 seconds minus 1 times 240 seconds plus 1 over 12 molar. Okay, so this gives me 26.4 Okay. And I may want to just, hey, that's my final answer and plug it in. But that's not right. It's not right for 2 reasons. First, notice that I started off at 12 molar, and this is a reactant, so it should be decreasing. So how could I have more? Well, something's wrong. Notice how this is not my concentration, it's 1 over my concentration. And notice the units aren't in units of concentration, they're in units of 1 over concentration. So I have to calculate A. And so this will be 1 over 26.48. Okay. What I did was I multiplied by this and then I divided by that, or I just flip both sides. And so this is going to give me my concentration, I'm going to use a handy thing on my calculator where I just go ahead and I use this 1 over x button, and that flips it. And this gets me 0.038 molar. And that's my answer. All right, so that was second order. Notice in second order, I don't have to worry about it becoming negative, but I do have to worry about and make sure I flip it at the very end. All right, here it is on the screen. We went ahead, we plugged everything in, and then we did this last step, which is the flipping. Okay, and once again, here are both those steps, right? We have the same variables, but our equation is different. That means how we do it is different. So always be careful about whether it's 0 or first order or second order. By the way, there's one way to tell, right? Notice these K's, they have different units. And so those units can also be used to give away whether it's 0 first or second. All right, so that's it for lesson 10. Talk to you later.